Hey there. So I just want to talk to you a little bit today about the transferability of computer system management. And so in the computer system management unit, we've looked at inputs, outputs, processing, and how those things link together to make decisions in controlling whether it's an engine or a transmission or all of those different things in a vehicle that are computer controlled. So obviously today I'm not in my classroom. I'm standing here in front of my garage door. and I'm just going to use my garage door as a little whiteboard and talk to you about a situation that just came up with my hot tub. And so my hot tub has a top panel, and that top panel has a code on it that says FLO, or flow switch open. So I had to Google a little bit and find out what is that code. So it says flow switch open. And there's two codes: flow switch open, flow switch closed. Okay? And so flow switch open means that the pump, number one, the main pump, is running, but the flow switch is open. Okay, so that means that shouldn't normally happen. Flow switch closed means that the pump is running, but the pump isn't running, but the flow switch is closed. And that's not supposed to happen. So that's all you get when you Google, okay? And you get a little bit of information about codes. So you can't just find answers on the internet. We have to use a little bit of what we know about computer system management and start putting things together. So let's look at what a hot tub is and what this system is. Well, in the hot tub, we've got a main computer panel, okay? It's a processor. It's like the PCM on a vehicle. The top panel is like a scan tool per se, right? It's reading the code that main computer is sending up, and it's telling it to me as an owner, hey, we've got this code. Okay, and the top panel is also a spot where I can make controls and tell that computer to do things. So that's my giving an input, just like when I step on a gas pedal, right? It's just like pressing the up button on a jet or a heat or something like that, right? So that's what that top panel is. So the top panel is letting me communicate with this computer. The computer also sees inputs from various sensors in the hot tub, like this pressure switch. So it's seeing some information from the pressure switch to try and tell me what's going on, okay? Now, as just a normal hot tub owner, I could go and bring in a technician and pay my hundreds of dollars, or I can transfer some of the knowledge that I've learned as a technician to try and figure this out, okay? So let's look at what a pump is, let's look at hydraulic pressure, and let's look at what these codes mean and do some deductive reasoning to see what actually is going on. Okay, so we have a pump. A pump creates flow and pressure. Okay, so we have a electric pump. Okay, and that electric pump is turning what we call a wet side, right? So the electric motor is turning a hydraulic pump or a water pump. So in hot tubs, they call it a wet side, dry side. But so this is electric motor, and this is the pump. Now, that pump creates flow, okay? And pressure if there's restriction. The restriction actually creates pressure. So the jet's restrictions create the pressure buildup for us, right? So on this pump, there is a pressure switch in a little heater circuit. It just happens to be threaded into the same spot where the heater is, okay? Now, that pressure switch is a switch. Now, I'm not actually going to tell you how it works yet. I want to tell you how I figured out how it works. So the code said FLO, meaning the pump is on, okay? So the pump is running, so it knows this is on, okay? And so there should be flow and pressure from the restriction, but the switch is open, okay? And that's a bad situation. So that tells me that this switch should be closed when there's flow and pressure pushing on it. Now there's another code that says flow switch closed. Now that means that the pump isn't running, so there's no flow, okay? So the pump is off. So it knows this isn't running. The pump is shut off, so there shouldn't be any pressure here, but the switch is closed, okay? And that's a bad situation as well. So that tells me that this switch here should get closed when there's pressure and flow, and should be open when there isn't pressure and flow. So what type of switch and how could this work? Well, this switch must have some sort of a diaphragm in there, like an oil pressure sensor switch, that senses the pressure of the water when it has to go through all the restrictions. So the pump creates a flow, the restrictions create the backup of pressure, and we get pressure pushing on a diaphragm, and that diaphragm would close some sort of a switch. I guess it would be down on this side. It would close some sort of an electric contact, close that switch. So now the main computer, okay, so the processor would have an input from here, okay? And so it's likely doing it something like a 5-volt reference, like in automotive. And it's sending a signal here, and if it can get through and come back and it can see that it completed its circuit, it knows that everything's good because the pump is on, this is closed, so it says, all right, pump's running, we have our pressure, okay? When the pump shuts off, it should be normally open. So we take this pressure away, diaphragm moves down, switch moves open, and now this circuit can't complete. So the computer knows, okay, pump's off, and we don't have contact in the switch. So we don't have pressure, so everything matches up. Okay? So that's what we would call deductive reasoning, right? We've taken and deduced how this works based off of the conditions of that code setting. Okay, so we can take these same principles of computer system management and learn how the system works. But now I need to diagnose it. Okay, so big deal. I kind of understand how it works. So I've got this code here, flow switch open. Well, that means one of two things. Either the pump is running, okay, the motor is running, and the pump is either pumping and creating a pressure and flow, but this switch isn't closing like it's supposed to, okay? Or there's a break in a wire, okay? So this circuit is open somewhere. Or the pump actually isn't running. So the motor is running, the computer thinks the pump's running because it's turned the motor on, but maybe the shaft's broken or the key's broken and I'm not getting flow, so then I can't get the pressure that I need. So one of those situations needs to happen, and this is identical to automotive computer system management, okay? We've got an input, we've got a processor, we've got an output, which is this motor, okay, and the pump that it runs. This is not an electric component, it's just a mechanical pump ran by the electric component. So we've got this same input, processing, output, and a code, which I'm reading from my scan tool, which is my top panel. Okay, so I start to ask some questions to myself. First off, I have flow, I have pressure. I turn this on, this works, the pump turns, I get all kinds of flow and pressure. So I know that mechanically this works. I know that the output control works, okay? So now I need to start looking at this switch and the circuitry. Okay, so I could check continuity with a multimeter between here and have that to see if that wire is broken back and forth. If I could get some sort of a schematic and see if it is a 5-volt reference, I could, check for, measure for that 5 volts here and, check if there's continuity here and what goes on in the circuit board. But I don't have those schematics, so I would likely just use ohms, unplug it here, see if I've got continuity back and forth. But prior to doing that, I'm thinking that this is likely the issue. Okay, there's no movement under the hot tub. There could be some corrosion, but it's pretty sealed connectors. So I'm guessing that these wires that are just ran and sitting there likely aren't damaged. So the most logical place to look would be in this switch. So it's either one of two things. Either the switch is faulty and something's broken in here and it's not making contact, or it is actually an adjustable switch. Okay, so it has an adjustment here that puts spring pressure on that diaphragm. So if it's cranked down too far, so that there'll be some sort of a threaded top on it, if there's too much spring pressure on this diaphragm, then the pump pressure can't push against that spring enough to close the switch. Now my problem is intermittent. Sometimes it works, sometimes it doesn't. So I'm guessing that very likely it's just an adjustment where I need to back that screw out, take away some spring pressure, allow that diaphragm to push up easier, and close that switch. Okay, so I'm guessing that's likely the issue. And I guess I shouldn't use the word guessing. I'm using all of this information I know through computer system management to pick the most likely cause. That's what I mean by guessing. Okay, so we're going to look at that. We're going to have a look at the adjustment and see what's going on. So let's stay tuned and let's go have a look at this real situation. Okay, so here we are at the hot tub now, and here's the top panel that I'm talking about that acts kind of like a scan tool because it's communicating with the main computer that's inside the hot tub body. Now you can see here that it doesn't have the code. I told you it was intermittent, and so the code has actually shut off in the 10 minutes where I talked to you about how this system works. And that's what it's been doing. It's been going on and off. But where it says 97, it did say FLO. So if I turn pump 1 on, okay, so pump 1 is running. So you can hear that it's running. We can see that we have the flow, okay? And obviously the pressure will be back building because the jets are restricting the flow. And there is no code, okay? But it used to say, just this morning, it said FLO right here, and everything still was operating as is, okay? So if we take a look down here, now this is very similar to automotive because I don't want to crawl under my deck and take this stuff all apart unless I have to. So figuring out the most logical cause first, based off of how things work, is likely, is always easier than just starting to do the difficult things to start with. So bear with me as I get the camera positioned here. So there is the pressure switch there. Now you can see that there's 2 wires to it, so I could visually inspect wires like I talked about. But right on the side of the switch there, I'm trying to get some light on it for you. There, you can see it good there now. You can see that little wheel kind of about halfway down. That's an adjustment, okay? So just like I said, so there is an adjustment on this switch that it changes the spring pressure. And so I assumed that it's adjustable or changeable, one or the other. It's either just a part that fails that needs changes or there's some sort of an adjustment. So that would be logical. And then I did a little more research, right? I phoned the hot tub place and talked to the experienced technician and confirmed that, okay, it's an adjustable switch. Now, what makes sense is to back that little adjuster knob out. Okay, I don't know if I can reach and run the camera at the same time here, but we'll give it a shot. Okay, so, no, I can't. So, that little adjuster knob right there, I'm going to back that out a few turns to move that spring up this way, which will take away the spring pressure that's pushing on that diaphragm. That diaphragm will be right in this area here, okay? And we'll do that. We'll give it a couple turns, and we'll just see if that code comes back on. If it does, I'll do it some more and back it out. And if it continues to fail intermittently, then I'll get in and I'll start doing, some resistance checking of wires. I'll do a physical check of continuity and corrosion while I'm here, because this is in a wet area here, and it is sealed up in here. There's the main computer. So it just looks like automotive. All the connectors going in, and they're all sealed connectors, so the chances of corrosion and things in there are unlikely. Okay? So, yeah, so that's pretty much it. So that's what we're going to give it a shot, and there you go. Okay, so we're back here now in my garage door classroom. Hopefully you've captured most of this. I think I may have cut off some of the ends, but I think you get the gist of how this is a transfer problem. So in conclusion, this is what we're trying to teach you in education, okay? We want you to take information, everything that you learn in education, and be able to transfer that to your lifelong learning, okay? That's what it's all about. At the end of the day, I don't care so much that you understand how a 2006 Chevy Malibu mass airflow sensor affects the way that it controls fuel, okay? Yes, it's important to have some understanding about those concepts for being a good vehicle owner, but more so, I want you to be able to take that type of learning and apply it to random situations like a hot tub. It's the same as your reading. It's the same as your writing skills. Okay, we as teachers don't necessarily care that you can write an essay on one topic, but that you can write literally in all your writings throughout your life. Okay, so that's what education is. This is a perfect example of transfer, and I hope that's helped you see how all we learn in education can be transferred to your lifelong learning.